Okay, so our next topic is steam turbine. So steam turbine is, of course, it's a very important topic, and it is an important component in any steam-based power plant, and it's a very important the mechanical equipment. And so here in our syllabus, so we just have to learn about the basics of steam turbine. We don't have to go into depth of mechanical construction details and things like that. So we will be just focusing on the basic equations to calculate work done and efficiencies and things like that. So the broad classification of steam turbine is into impulse turbines and reaction turbines. Okay, so most of the turbines can be simply divided into either impulse turbine type or into reaction turbine type. So anyway, we will see the major differences later once you learn reaction turbine also. So first, let's focus on impulse turbine today. So in impulse turbine, so basically as the word suggests, it is something to do with impulse. അതിൽ മെയിനായിട്ടുള്ള കാര്യം impulse ആണ്. So impulse എന്താണ്, anyway you know it already. Anyway, you have learned about impulse of jets in fluid machinery also. Okay, so you know what is impulse. So impulse turbine works on the principle of impulse. It works on the principle of conservation of momentum. Okay, so impulse turbine ഏറ്റവും ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള കാര്യം, first you need steam nozzles. Okay, you need steam nozzles which convert the enthalpy of steam, okay, enthalpy of steam, the high energy of steam into high velocity. Okay, so conversion of enthalpy into kinetic energy. കാര്യം എന്താണ്? So because we need a steam jet with very high velocity coming into impulse turbine, because it works on the principle of impulse. Okay, so you need to create a strong impulse. So you need a steam jet with very high velocity. So to get steam jet with very high velocity, you need steam nozzles up front. That is the most important aspect of an impulse turbine. Okay, so now let's see the diagram of an impulse turbine. Okay, so it is something like this. So I guess it is clear now. Okay, so basically in a turbine there will be a shaft. Okay, the turbine shaft, and then there is a wheel attached to the turbine shaft. So this wheel will be rotating, and there will be blades attached to the wheel. Okay, so this is the simplest diagram that you can think of on an impulse turbine. Okay, so shaft, wheel, and then blade. Okay, and as I said, steam will be coming through nozzles. Okay, steam coming from boiler, it passes through nozzle, and once it is out of nozzle, so anyway this will be a convergent divergent. Okay, initially it is convergent, then it is diverging. So this is a convergent divergent nozzle, steam nozzle to get very high velocity. Okay, അങ്ങനെ very high velocity കിട്ടിയതിന് ശേഷം it comes and impinges on the blades and it goes out. So the momentum at the inlet, okay, and the momentum at the exit, so that difference and basically gets converted into the work. Okay, our difference in energy ondana ee turbine karangan പോകുന്നത്. Okay, so now if you see this set of diagram, it is still better. Okay, so steam coming in through nozzle, it is passing it is impinging on turbine blades. Okay, so turbine blades കറങ്ങിക്കൊണ്ടേയിരിക്കുകയാണ്. Okay, so these are steam nozzles. Okay, steam nozzles are fixed. Okay, these are fixed, but as you can see, the other set of blades which are the turbine blades, so those will be moving. See, these are moving blades. So ഇതിങ്ങനെ മൂവ് ചെയ്തുകൊണ്ടിരിക്കും. So ഇത് മൂവ് ചെയ്യാൻ കാരണം എന്താണ്? Because this will be coming and hitting, and it will be passing between these blades. Steam will be coming and hitting and impinging on the blades, and it will be passing between these blades also. So ഇങ്ങനെയാണ് ഇത് ബേസിക്കലി വർക്ക് ചെയ്യുന്നത്. Okay, and now we need to see how exactly you can calculate the work done and efficiency of impulse turbine. Okay. So as I said, once again, impulse turbine is something that something that works on the principle of conservation of momentum, and so and again you need to remember, so what exactly is the conservation of momentum. So the momentum of jets at the inlet to the blades minus momentum of jet at the exit from the blade. Okay, so both result in the direction of the rotation of wheel. Okay, so momentum at inlet of the blade minus momentum at exit of the blade, both in the direction of the moment, that is equal to the momentum absorbed by the wheel in producing work. Okay, that difference is what drives the turbine. Okay, that difference is what that drives the turbine. Okay, so wheel rotates only due to the difference of moment of jets deflected by the blades. അപ്പോൾ ഈ ഒരു ഡിഫറൻസ് ഇൻ മൊമെൻറ്റം അറ്റ് ഇൻലെറ്റ് മൈനസ് മൊമെൻറ്റം അറ്റ് എക്സിറ്റ്, ഈ ഒരു ഡിഫറൻസ് കൊണ്ട് മാത്രമാണ് ഈ ബ്ലേഡ്സ് റൊട്ടേറ്റ് ചെയ്യുന്നത്. ഇറ്റ് ഈസ് ദാറ്റ് ഡിഫറൻസ് വിച്ച് ഡ്രൈവ്സ് an impulse turbine. So ഓർമ്മിക്കേണ്ടത്, സ്റ്റീം നോസിൽ കൂടി സ്റ്റീം പാസ് ചെയ്ത് കഴിഞ്ഞാൽ then there won't be any change in its enthalpy. Okay, because the entire enthalpy change takes place in steam nozzle. Okay, after that it is just about velocity. Okay, just about velocity, and there won't be any more pressure drop. Okay, അപ്പോൾ ടർബൈനെ കുറിച്ച് ഡിസ്കസ് ചെയ്യുമ്പോൾ the most important thing is its velocity diagram. Okay, we need to draw its velocity diagram. So any velocity diagram can be again drawn in different way. So here anyway I just follow one standard textbook, the conventions in one just standard textbook. So this is the blade. Okay, this is the blade, and then this is the inlet, and this is the exit. Okay, so inlet blade steam comes with an absolute velocity v1. Steam comes in with an absolute velocity v1. Okay, so that is coming from nozzle. It comes with absolute velocity v1 at an angle alpha. This angle this angle is nothing but nozzle angle, because nozzle is kept at an angle. Okay, with respect to blades, nozzle is kept at an angle, and that is nozzle angle. So v1 എന്ന് പറയുമ്പോൾ the absolute velocity of steam that is coming in, it is coming at an angle alpha. Okay, but at the same time this this blade is also moving. So the blade is moving with the velocity, say vb. Blade is moving with the velocity vb. So this steam impinges the blade at inlet. If a steam impinges the blade at the inlet with the relative velocity vr1. Okay, അത് ഹിറ്റ് ചെയ്യുന്നത് ആക്ച്വലി അത് എൻ്റർ ചെയ്യുന്ന റിലേറ്റീവ് വെലോസിറ്റി, ബിക്കോസ് ദ ബ്ലേഡ് ഈസ് ഓൾസോ മൂവിങ്. സോ ദാറ്റ് ഈസ് vr1. ഓക്കെ, ആ ആംഗിൾ എന്താണ്? ദാറ്റ് ആംഗിൾ ഈസ് കോൾഡ് blade inlet blade angle β1 with respect to horizontal. With respect to horizontal you have this angle, that is β1. So this is inlet blade angle. So v1 is the absolute velocity of steam coming in at an angle steam alpha, which is nothing but nozzle angle. But the blade has a velocity vb. So the steam enters with the relative velocity of vr1 at an angle β1, which is nothing but a blade angle. So similarly at exit the steam goes out with a relative velocity vr2, but again it has an absolute component v2. Okay, steam actually, if you look at the absolute velocity of steam that is going out, that will be v2. Absolute velocity is v2, but blade is moving with the velocity vb. So the steam jet will be going out with a relative velocity vr2. Okay, absolute velocity v2 ആണ്, blade velocity v2 ആണ്. So it goes out with the relative velocity vr2 through the exit blade angle β2.